Section 1.1 on exponential numbers. In this section we're going to talk about exponential numbers and some of their properties and how to simplify exponential expressions. Okay, so let's get started. So the first thing we need to do is define exponential numbers. Let's do that. An exponential number is any number that's of this form, where you have b to the n. Okay, what that basically means is you want to take b and multiply by itself n times. So you multiply b by itself n times. Okay, there are two very important things you need to know. This b is called the base and this is called the exponent. Sometimes people call it the power. So that's one thing to note. Okay, but the other thing that's very important is this, where n is a natural number. If you've forgotten what a natural number is, basically a natural number is a positive integer or a positive whole number. That means it cannot be a fraction, it cannot be a decimal, it cannot be a negative number, it cannot be zero, and so on. So this is a definition of an exponential number. Okay, so all you do is multiply the base by itself n times. Okay, where n has to be a natural number. You'll come across this terminology like natural numbers, integers, rational numbers throughout this class. Basically there are certain classes of numbers and they satisfy certain characteristics. In this case, the natural numbers are a set of positive integers. Okay, all right. So now that you know what an exponential number is, let's take a look at some examples. Here we have 5 cubed. Where the base is 5, the power is 3. So that basically means you multiply 5 by itself 3 times. So we get 5 times 5 is 25. 25 times 5 is 125. Here's another example. I could have 2 raised to 4 and multiply 2 by itself 4 times. In this case, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. 16. Now, those were two very simple examples. You probably have seen them before in some algebra class, but let me point out a couple things. Just note, I usually have a tendency to point out a few things that are important to you, or a few things that I see students make mistakes on over the years, and I do like to stress them so that way you can avoid those same mistakes. Now, let me give you 3 examples and I would like you to calculate those values. Take a minute and do them and see what you get. So the first one is this. I have 7 squared. That's easy. Second one is minus 7 squared. And then the third one is negative 7 squared. So these are things that I truly want you to remember, because these are common mistakes students make. Whenever I ask students to tell me what is 7 squared, they'll tell me it's 7 times 7, which is 49. That's true. That's a good answer. If I ask them what is minus 7 squared, they'll tell me it is also 49. That's a wrong answer. And I'll show you why. Now, if you look at this problem, the power or the exponent is only on the 7 here. If they want you to square minus 7, they'll always put parentheses like they did over here. So that is a subtle mistake that students always forget. They think that minus 7 squared means it's negative 7 times negative 7. That's not the case. It basically, what this means is you have the negative on the outside and you want to square 7. So you get 7 times 7, because we're going to just square 7 like we did up here. And we end up with negative 7 times 7 is 49. So that is the answer. So please remember, if they want the base to be negative, they will always put parentheses around that number. If they don't have parentheses, that means that base is not negative. So in this case, since they have parentheses around the number, my base is minus 7, so I want to take negative 7 times negative 7. We end up with positive 49. So these are little subtle things that you do need to be aware of. These are very common mistakes students make. So please try to avoid them. Okay. Now that we looked at some examples of exponential numbers, let's take a look at some of their properties. So these are properties of exponential numbers. And there are many properties of exponential numbers, but I will tend to give you the ones that I feel you will need in this class. Exponential numbers. Okay, so let's take a look at them. The first property of exponential numbers is an important one because we stipulated that n had to be a natural number. So when we say that, which means a positive integer, that means that n cannot be 0 or negative. So what do we do if n is 0 or negative? So let's take a look at those, because we have special properties for that, since n cannot be 0. So if your base is b and your exponent is 0, then the value of that exponential number is 1. So here's an example of that. I'll try to give examples next to it. I could have 6 raised to 0. That would be 1. Okay, so the next property of exponential numbers deals with what happens if the exponent is negative, since n cannot be negative. It could have b to the minus n. So if you notice n is positive, the negative on the top makes the exponent negative. So in this case, what we can do is we can rewrite this as 1 over b to the n to make that exponent positive. Or you could have it like this. You could have 1 over b to the minus n. In that case, we could move it to the top and make that exponent positive. Now this is a very important property because, for example, if I give you 2 raised to minus 3, well, according to the definition of exponential number, what does it mean? I want to take the base, which is 2 in this case, and multiply by itself negative 3 times. Wait a minute, I can't do that. If it was just 3, I could do it, but I want to multiply the base by itself negative 3 times, so we cannot do that. So the first thing we need to do is make that exponent positive, so we move it to the denominator. Now I can do that. I multiply the base by itself 3 times, so you get 2 times 2 times 2, which is 8. So the answer is 1 over 8. Okay, so that's something you do need to be aware of. Okay, and when we talk about negative exponents, if you can move it to the bottom, it'll become positive. If the exponent was negative in the bottom, then you can move it to the top and it'll become positive. Okay, and we only worry about the base, nothing else. Okay, we move that exponential number to the top. The next property of exponential numbers is this: if you're multiplying two exponential numbers that have the same base, then what we end up doing is we end up adding the exponents. So here's an example of that. If I have 2 to the 2 multiplied by 2 to the 3. Now before I use this property, let me show you why this property works. 2 to the 2 means what? You multiply the base by itself 2 times. 2 to the 3 means what? You multiply the base by itself 3 times. So how many 2's do I have here? 2 to the 5. We got 1, 2, 3, 4, and 5. So that's exactly what this property is telling you. You take, since the bases are the same and you're multiplying them, you add the exponents. So we end up with 2 to the 5. So if you multiply 2 by itself 5 times, you get 32. Okay. The next property of exponential numbers is this: if you have b to the n raised to m. Okay, I have an exponential number on the inside now, and then I also have an exponential number on the outside, because this is my base now and this is my exponent. So I have two exponential numbers next to two exponential numbers in this problem. So in this case, what I can do is I can just multiply the exponents. So if you have one exponent and another exponent next to it like that, you can multiply those exponents. So let me go ahead and show that to you. Okay, so if I have, let's say, 2 squared raised to 3. Well, let me first show you why this property works, and then we'll take a look at it. Okay, so 2 squared is the same thing as 2 times 2. So I want to take this as my base now, correct? I want to take my base and multiply by itself 3 times. So you get 2 times 2, that's once. 2 times 2, that's another time. 2 times 2, that's a third time. So how many 2's do I have now? 2 raised to 6. So instead of going through all that work, I can just use this property, which tells me what? If you have an exponent raised to another exponent, you can just multiply those exponents, and we get 2 to the 6, and 2 to the 6 is 64. 2 times 2 times 2, 6 times is 64. So again, I've given you the explanation why these properties work. The next property of exponential numbers is this. Okay, if you have a times b to the n, so if you have two things on the inside raised to the n, and we can rewrite this as a to the n and b to the n. So we can basically apply that exponent to each thing on the inside is what we are doing in essence. Okay, so we can apply that exponent on each thing on the inside. So let's take a look at this example of this property. I could have 5x cubed. That means, according to this, I have two things on the inside here, multiplying them, so I get 5 cubed and x cubed. It's not really what you're doing, but you can think of it as distributing that exponent. Okay, so we get 5 cubed is 125, and x cubed is just x cubed. Okay, and there's a similar property for division, so let's take a look at that. I have a over b to the n. That basically means I have a to the n divided by b to the n. So I'm distributing that exponent. Again, you can think of it that way, but that's not what mathematically is happening, but it's a good way to visualize that. So let's say if you have 2 over 3 to the 4th power. So we get 2 to the 4th power divided by 3 to the 4th power. We can move that exponent there. 2 to the 4 is 16, and 3 to the 4 is 81. There's your answer. So those are properties of exponential numbers. Now if you open a lot of other textbooks, you'll come across many other properties of exponential numbers. But if you know these few properties, that's all you need to worry about. Okay, so those are 6 properties you need to know. So let's take a look at how we can utilize these properties to do the last thing in this section, which is what we want to do is we want to simplify exponential expressions. As you're doing math, you'll come across terminology like we saw natural numbers earlier and so on, and I'll try to explain them to you, and hopefully you will keep in the back of your head those definitions. Like for example, simplify basically means is make it simple. That means, combine whatever you can combine, get rid of whatever you can get rid of, and so on. Just crunch the expression down to so it's easier to look at. I always tell my students to think of it as easier to look at. Okay, and that you'll come across that a lot. We simplify a lot of expressions in algebra, so it's a common terminology. Alright, so let's take a look at an example on what we mean by that. So let's start with something really simple, and then we'll move our way to a few more complicated examples. Okay, so let's say if I have 4x raised to negative 2 y cubed raised to 2. Now I want to simplify this. This looks really ugly because I have some negative exponents, and we said earlier exponential numbers are written like this. That means the exponents always have to be positive. Okay, natural numbers, we talked about that, so we can't have negative exponents. And then we have exponents, and then we'll have another exponent on the outside, so it looks fairly messy. So let's simplify this. Okay, so let's do that. The first thing we'll do is we're going to use those properties that we just talked about, and there's many different ways to do that. So if you ask someone, they might show you a different way to do that than I'm going to do it. I'm trying to show you a method that I have come across over the years that I find is easier for students to digest. It might seem longer in some cases, but it's always going to work if you follow the method. So the first thing when I do these problems on exponential numbers is I get rid of the outside exponent. Okay, so the first thing I do is get rid of the outside exponent. And to do that, To do that, I'm going to use this property 5 and 6, depending upon what my problem is. So I'll put the properties down in parentheses, 5 and 6. The second thing I do is make negative exponents positive. I'll abbreviate exponents, make negative exponents positive. That's property 2. And then the last thing we can do is we can cancel or combine, and that's property 3. Now, again, in some cases these steps will make your problem longer, but if you follow them you'll still always get the right answer. So it's a good idea to always have, and math is all about doing everything systematically. It's students usually get into trouble is when they start taking shortcuts or trying to be creative. So if you just try to stay consistent by following the steps, or so that way anytime you're learning something new, it's always good to follow some guidelines or follow some steps till you master it. Then you can start taking shortcuts. So for now I would really encourage you to do that. So the first thing I'm going to do is take this outside exponent and apply that to everything on the inside. So I get 4 squared, x raised to negative 2 times 2 is negative 4. Remember, out here we are also using, I should really put down a couple properties here. It should be property 5, 6, and 4. Because property 4 was what? If you have an exponent already there and you have another exponent, then you can multiply those exponents. Okay? So in this case I'm using property 5 also. So negative 2 times 2 is negative 4, and y raised to 6. The next step is we want to just make negative exponents positive. This is the only number that has a negative exponent in it, so that number needs to go to the denominator because it needs to become positive when you move it there. And 4 squared we know is 16, so we get y to the 6, and then on the denominator we get x to the 4, and there's your answer. That's all we need to do. Okay, we didn't have to worry about the last step here, but let's take a look at an example where we do. So here's another example. So let's say if I have negative 2 a to the negative 3b cubed raised to 2 divided by 4a to the 3b to the 2 cubed. Okay, so let's take a look at this example. All right. So first thing we're going to do is same thing, take care of that outside exponent, get rid of this, so distribute that in. Again, I use the word distribute, not the right terminology, but it helps for students to do that. And always try to do your problems vertically. Don't do it this way. This is equal to this, this is equal to this. That is really terrible way to do math. You never see math textbooks written that way. Problems are always done vertically. So in this case we get negative 2 squared. Now if you notice I put parentheses there because this number is negative here. So I want to put the exponent on that whole number, not just the 2. If I had written it this way, then I would be just squaring the 2. Remember we talked about that, so it's important that you put those parentheses. We get a to the negative 4, we get b to the 6, divided by 4 cubed, a to the 9, b to the 6. Right? The next thing we want to do is make negative exponents positive. So again, only this exponential number is negative, so I'm going to move it to the bottom to make it positive. Everything else stays where it is. I can take care of some of these few simple calculations. Negative 2 times negative 2 is 4. I get b to the 6 on the top. On the bottom we get 4 cubed is 64. Then we get a to the 9, b to the 6, and then a to the 4. So that a to the 4 comes to the denominator. So now we can simplify. Now we're going to do the last step. The last step is what? Cancel and combine. Well, let's see what cancels. Well, 4 and the 64 cancel because 4 goes into 64 16 times. That's good. B to the 6 cancels with B to the 6. We can always cancel in math if you have multiplication, which is what we have here. If you think about it, I have 6 b's on the top because b to the 6 means what? You have 6 b's on the top and you have 6 b's on the bottom, so you can just cancel those. Okay. And out here on the bottom, what else do we have? We have a to the 9, we have 9 a's on the bottom, and we have a to the 4, we have 4 a's on the bottom. So the total number of a's on the bottom we have 13. On the top everything cancelled, so we just get a 1. On the bottom we had 16, a to the 13. And that's the answer to that. Okay, we're using property 3 to do that. Property 3 told us what? If you're multiplying two exponential numbers where the base is the same and you're multiplying them, then you can add those exponents. That's what we just did there. Okay, let's take a look at another example here. So in this case we have, we have 3a cubed b to the negative 8 divided by 6a to the negative 5 b to the negative 1 to the negative 2. Okay, now again, I've stressed this before and I have a tendency to repeat myself just to drive home the point. There is really many ways to do this problem. There's faster ways to do this problem, but I'm trying to stick to the steps that I gave you a minute ago here. Okay, so please try to remember that. There's better ways to do this sometimes, faster ways, but I want to be consistent. So the first thing I'm going to do is take this negative exponent and push that to everything on the inside, since that exponent is on the whole expression there. So I get 3 to the negative 2. I get a to the negative 6, b to the 16. I'm just multiplying them. 3 times negative 2 is negative 6. Negative 8 times negative 2 is 16. Then I get 6 to the negative 2, a to the 10, and b to the 2. Again, we're just doing that. Alright. Now, the next thing we want to do is make negative exponents positive. So you just have to identify your negative exponential numbers. In this case, this number has a negative exponent, so does this number. So both of those need to go to the bottom. On the other hand, in the denominator, only this number has a negative exponent, so that needs to go to the top. The only ones we move are those numbers with negative exponents. So let's rewrite this a little bit. So I still have b to the 16 left on the top. Then I'm going to move this to the top, so you get 6 squared, and that's it. On the bottom you have a to the 10 left, b squared, and then you're going to move these two things to the denominator, 3 squared and a to the 6. Alright, we took care of the negative exponents because we cannot have negative exponents. If you remember the definition of exponential numbers, this exponent has to be a positive integer. So that's why we're taking care of those negative exponents right away. Now we can combine and cancel. Okay, so in this case 6 squared is just 36. Okay, so I get that. And then if you notice, how many b's do I have on the top? Because b to the 16, that means you have 16 b's on the top. I have 16 of these. And how many do I have on the bottom? 2. So I can cancel at least out of these 16. If I have 2 on the bottom, I can cancel these 2, so I'm left with just 14, because out of those 16 I got rid of 2 of them. So I can do that over here. I can get rid of this and make this a 14. So on the top I have b to the 14. Okay. On the bottom I have 3 squared, which is 9. And then you have a to the 10 and a to the 6 on the bottom. So you have 10 a's over here and 6 over here. So the total number of a's on the bottom we have 16. Okay, and you might think you're done, but in this case we can reduce some more because 9 goes into 16 4 times. So my answer is going to be 4b to the 14 divided by a to the 16. Okay, so when you're doing these problems, if you follow those steps that I gave you, you can see how easily you can do those. You might end up doing a few extra steps, in some cases, like in this one, but it still works out perfectly fine. Let's do one last example. Okay, we have 5a to the minus 1, b cubed, c to the negative 2 squared divided by minus 3 a to the minus 2 b to the negative 3 c to the 0 cubed. Okay, let's make this a negative 3. Alright, so let's do this. Now before I do this problem, one of the properties of exponential numbers was what? If you have b to the 0, then the value of that exponential number is just 1. So in this case, you notice I have c to the 0 here. So I know that this is just 1, so I don't need to worry about that at all. So let's take care of that right away so we don't have to carry that along. Similarly, let's say that this exponent on the outside was 0. In that case, this whole thing would be 1, because anytime the exponent is 0, the value of that exponential number is always 1. But we'll go back to negative 3. So we took care of this part right away. Always do that if you can. Just take care of certain things out right away so you don't have to worry about that. Now let's take care of the outside exponent. So let's apply that. So you get 5 squared a to the negative 2 b to the 6 c to the negative 4 divided by, again out here there's a negative number here, you can see that. So when you apply the exponent, you have to apply that to the whole negative number, so we need parentheses, negative 3 to the negative 3, a to the 6, b to the 9, and then c is gone. That's what we have. Okay, so please remember, if you have a negative number, you need to apply that exponent on that whole thing. Okay, not just on the 3. This is not the same as this. Is that okay? So keep that in mind. We've talked about that. So let's take care of the negative exponents next. I have a couple things on the top that have negative exponents, this one and this one, so they both need to go to the bottom. And on the bottom I only have one quantity with a negative exponent, this one, that needs to go to the top. So let's just rewrite it for a second. I have 5 squared b to the 6th, that stays on the top, and this comes to the top here. Okay, and on the bottom we have a to the 6, b to the 9, and then these two yellow things go to the denominator, so you get a squared c to the 4. Okay, oops, this becomes a positive exponent when we move it to the top. I'm just going to do it, I'm running out of space, that's why I'm going to do it on the side, but I would prefer that you guys do everything vertically here. Okay, so 5 squared is 25. Okay, and then we have, I'm just going to rewrite it one more time, so b to the 6, negative 3 cubed, so you take negative 3 times negative 3 times negative 3, so you end up with negative 27. So I'll put parentheses again since it's a negative number. Okay, then we're going to divide that by a to the 6, b to the 9, c to the 4, and a squared. So we took care of a negative exponent. The next thing we want to do is what? Cancel and combine. So let's do that. So over here, if you notice, I have 6 b's on the top. I have b times b times b times b 6 times, and 9 on the bottom. So I can get rid of this 6 and make this a 3. Because out of those 9, I can cancel the 6 of them. I'm left with just 3. And that's about it. Nothing else cancels. Let's combine these two, not combine, but multiply these two things, because we're multiplying them. So I get negative 675 on the top. There's no b's left on the top. On the bottom, I have 6 a's out here, and then I have 2 more a's over there, so I have 8 a's on the bottom. I have b to the 3, c to the 4, and there's your answer. Okay, and that's how we do exponential problems. Alright, so, and you can see in all of these cases, I should have pointed out before, you know, like for example this one, that looks really ugly with all these extra exponents and things like that, but after we simplify it, isn't that easier to look at what we have over here? Okay, oops, this one's a lot easier to look at. Similarly over here too, if you notice, this problem is a lot more difficult, okay, to look at, or messy to look at, but this one's a lot easier to look at. So simplifying does make your things a lot easier on your eyes. Alright, even though I said that was the last example, let me just do one more. So we have 5x to the minus 1, y to the negative 4, divided by, I have 3y to the 5 raised to negative 2, and I have x to the 9. So let's just do this last one. And as you're doing these examples, once I do a few of them, then when I start the next one, it would be a good idea to just pause the video and try to do it on your own, and then play the video, start the video again, and check the answer. It's always a good idea, always practice your own problems. Okay, so let's do this. I don't have any outside exponents on the top to worry about. I only have one thing with an outside exponent. So let's take care of that, distribute that. So we get 5x to the minus 1, y to the negative 4, divided by 3 to the negative 2, y to the negative 10, x to the 9. So I took care of that outside exponent. Now we want to make negative exponents positive. So I have two things on the top that have negative exponents, so they need to go down. And I have two things on the bottom that have negative exponents, so they need to go to the top. So let's rewrite this for a second. I have 5 stays on the top. 3 to the negative 2 goes on the top, so it becomes a positive exponent. Y to the negative 10 goes on the top, so the exponent becomes positive, divided by x to the 9 stays on the bottom, but I have two things coming down. X to the minus 1 goes to the bottom, so it becomes x to the 1, and y to the 4. Again, I'm going to do this on the side since I'm running out of room. I have 5 times 9, because 3 squared is 9. Okay, that's what I have left there. And then over here I have 10 y's on the top, and I have 4 on the bottom. And since I have multiplication, I can cancel. So I can get rid of these 4 and make this 10 into a 6. So I get y to the 6, because I had 10 of them. Out of those 10, I got rid of 4. On the bottom, I have 9 x's and 1 more x there, so I have x to the 10. And you might be happy with this answer, but remember, this is multiplication here. I can still multiply these two. So I get 5 times 9 is 45, y to the 6 divided by x to the 10. So there's your answer to that problem. So I hope you followed the idea of exponential numbers and learned some of its properties, and also learned to simplify exponential expressions. The best way to master a topic in math is always to do your own examples, to practice your own problems. So I would encourage you to take a look at the practice problems and practice them, and check your answers with the solutions to the practice problems, so you can see whether you did them correctly.